Okay, another TVR Chimaera cold start test. Now you may all be wondering why I'm sat in an Audi. Well, this is my other car, and it's got a very reliable temperature gauge on it, ambient temperature gauge. So we'll just what we'll do is we'll just pop that on there, and hopefully everybody can now see. It is 5.5 degrees C, so another cold day today, as we can see here. Also raining, which is horrible for LPG. The moisture in the atmosphere tends to cause condensation on the cold components, the vaporizer and the LPG filter. So actually on a cold 5.5 degrees day that's also raining and miserable is a perfect opportunity to test the cold start. All right, let's leave the Audi now and go to my car. Let's go to the TVR and have a look. Yeah, pretty rank cold day really. Okay, here's the TVR, sat in the garage. So what I've done is I've just lifted the bonnet, so I want to show you how stone cold it is. So here we are in the engine bay. Okay, so looking down into the engine bay, that's me on the exhaust manifolds. Obviously I wouldn't be able to do any of that if I'd started it today. It is absolutely stone cold. In fact, these pipes are very cold to the touch, as is obviously the LPG vaporizer that we'll be looking at when we do the start. And then draw your attention to the filtration system here that I've mounted just forward of the exhaust, and we'll come back to that in a minute. Okay, here are the offside bank of injectors. So they're sitting on the rocker covers. They take a little while to warm up, but they do get radiant heat from the rocker covers once the engine warms, which helps again. So as we all know, you can't really start an LPG car, of course, in the cold and wet like this. But we're going to prove you actually can. Right, so now we're in the car. I want to have a little look at my super cheap gauge, and it seems to be showing about 6 degrees. So the 5.5 that we're seeing on the Audi, I am in the garage here, so maybe that's the half a degree. But this was £1 from Tesco's, this gauge. So I think that's pretty close. Let's say it's 5.5 degrees because that's what the Audi says. So let's just have a look at the starting procedure. Now I've had an earth loop issue with my Can-Em's dual fuel ECU, which even the installers couldn't seem to rectify. I think I'll be able to put it right as the weather gets a bit warmer. I should be doing some earthing work on the engine, and should be able to put that right. But as a temporary measure, I've gone old school, fitted one of these. It's not a choke as such. It doesn't enrich in the air-fuel ratio on cold start. That's all done by the Can-Em's. All it is just a manual extra air valve. So like on your standard Chimaera you have a stepper motor, and on this one you have a Bosch pulse width modulated idle valve. In this case all it is just an extra air valve. It's actually a heater valve, which obviously, being completely watertight, is also completely airtight. So all it does is just allow sufficient air into the additional air that you need on cold start. So we pull it all the way out. So we'll go for a fully out position. I'm not convinced actually we need all that much air. We'll probably be knocking that off almost immediately after start, but let's open it up. I have also got an additional extra air valve for cranking, which is just basically a solenoid wired to the starter solenoid. And that pneumatic solenoid opens under cranking, so that assists with the extra air under cranking. As I say, this system here is really just a temporary measure until I get the earth situation sorted out. So let's have a look at the software and some of the features that you've got with the Can-Em system. Now this is a bit unique, of course, because it's a dual fuel system, so it operates, my vehicle operates on LPG as well as petrol. The majority of the cold start features are shared between the two. However, there are some influences on that. So for instance, This is cranking correction. So cranking temperature correction, so basically additional fuel put in under cranking. So you can see we're putting in 30% extra fuel here because we're pretty much midway on the 10. So if we just come down to mapping essentials, you can see that the coolant temperature, so ambient temperature is 5.5 degrees and coolant temperature is at 8 degrees C, which is about what you would expect. So this feature operates for both fuel types, petrol and LPG. However, there is an additional setting called cranking mixture where you can actually modify the cranking mixture, which is then influenced by the cranking temperature correction. So when I say cranking mixture, you can see here injector pulse width map 1 is petrol. So we've got 10 milliseconds there. And below is injector pulse width maps 2. Map 2 is LPG. We've got 8 milliseconds there. So less fuel times for LPG times by the correction that influences both. So 30% more fuel, but only 8 milliseconds on LPG. Also 30% more fuel, but in petrol times 10 milliseconds. Okay, so hopefully that's clear. Moving down, we've got running temperature correction, which is basically after the engine has started. So once the engine has started, it's applying, in this case, roughly around about 44%. So again here, 44% additional fuel. And as you can see, that kind of rapidly tapers off. 27% additional fuel at 20 degrees C. These are coolant temperatures, by the way. 125, so that's 25% additional fuel at 30. But by the time you reach 40 degrees, you can see it really does start to taper off. 117, and then at 50, 115. By 60, is only adding 3% extra fuel, 1% at 70. And by the time you get to 80 degrees, obviously, it's completely out of cold start enrichment. So that's basically a running temperature correction, and again, just as this upper one, the cranking temperature correction, these figures are for both fuels. However, just as I mentioned with the cranking temperature correction, the running temperature correction can be influenced by another feature, which I'll come to here, which is gas temperature correction. Now, this didn't come as standard with the Can-Am system. I asked David Hampshire of Can-Am's Engine Management to add this, because what this allows us to do is add further additional fuel dependent on the temperature of the LPG. So basically what happens is when you start the engine on gas, you have got no heat going around the vaporizer, and there's no radiant engine heat either. So basically what happens is, just like when you spray on your arm with deodorant, when you release a liquefied gas, it tends to freeze, it gets very, very cold, and because it's expanding, it's actually boiling at minus 40 degrees C. In fact, LPG, once you release it from its liquid state into its gaseous state. That's why you need coolant running around your vaporizer if you're running a gaseous system, and that's why it can be a bit difficult to cold start LPG vehicles in cold weather. However, what we've got here is a system that I'd asked David Hampshire to add for me. And what we can see here is, you'll see this when we start the engine, is that the LPG temperature, the gas temperature at the moment, is at 10 degrees. Well, that seems fine. But what you'll find is, as soon as you get a demand of gas, so when we start to crank the engine and it fires and it runs, you will see that temperature decline. In fact, what you'll see is it falling away from 0 all the way down to minus 10 and possibly even below. So this is where you get your freeze-ups. But at this point, you can see as the temperature falls, we're adding quite a little bit more gas again, so we're adding more fuel. So this is a correction table on top of the running temperature correction. So we're adding a further 15% as it gets down to 0, and 20% by the time it gets down to minus 10. If it reaches minus 20, which is unlikely, but it will come close, and it's 125, which is 25% more fuel. In addition to, if we go above, the 66% more fuel, or 20% more fuel under gas, and 61%, so that's 81% more fuel. That's a massive additional fuel amount, but I found this is what the engine needs. And again, 148, so 48 plus 115, so 15, so 48 plus 15 gives you the true fuel at 0 degrees, cold start, gas temperature correction. Hopefully that's clear. Basically, this feature allows me to manipulate this feature, but uniquely for LPG. And this feature is also shared LPG and petrol. However, can be influenced by this feature, the cranking mixture. So there are ways of adjusting the cold start scenario, the cold start map if you like, specifically to each fuel type. Okay, so here we go then. So we've opened up our idle valve, we've created some additional air under cranking, and what we're going to do now is just turn the ignition on. You should see now this will connect to the ECU. There it goes. And just to prove to you, we're on secondary maps, which means LPG. And just to prove it again, this switch here, we will just need to cycle the ignition to show you, because the light only comes on under priming pulse. The ECU is turned off after a few seconds. So I'll just cycle the ignition again. There goes the blue light. So again, to prove. Now what it's doing here is it's doing the priming pulse as well. It's just allowing some fuel in. I'll show you that feature very quickly. So here's the priming pulse feature. And the priming pulse gives us 16 milliseconds. That's as much as you can ever give it. So I've given it 100%. You see, you can't take it any higher. But it only does it below 65 degrees C coolant temperature. So it is only a feature that we use really in cold or partially cold start. Okay, so let's get back to turning on the engine and seeing how it starts. The other thing we're going to do is just show you. That's my leg, that's my right leg, that's my left leg, and the reason I'm moving those out of the way and showing you is just to prove to you that I'm not touching the throttle pedal at all to do any cranking. Throttle pedal way down there in the darkness. Okay, so here are the dials. We are in neutral, so we're going to crank. We are on gas. We've opened up the extra air valve to the maximum. We've made some adjustments since the last video on cold start LPG, where it fired on the third crank, and we're hoping that it's going to fire and run now on the first crank because of those adjustments to gas temperature correction. So here we go, LPG cold start experiment, 5.5 degrees ambient temperature, coolant temperature now down 7 degrees, very cold, engine completely cold as demonstrated by me touching the manifolds, and let's go for the start. And there we go, absolutely perfect, did not touch that throttle at all, and we're idling now around about 1800 RPM, a little bit high, so we could just bring that down. What I'm doing here is just slowly pushing in, try and get both things in the screen. So we're bringing that down. Okay, and there we are, much better. So now we're idling at 1200 RPM, stone cold. We'll come back to the data and we can see the coolant temperature has only risen to 9 degrees, so it's only come up really, so from 7 to 9, 2 degrees. We can also see we're frozen on the oxygen sensor, so we're waiting for that to warm up by the look of it. Let's see whether that comes online. Yeah, I think what's happening here is it is just very rich. Okay, so let's have a look at my other system, and yeah, we can see it's actually idling around about 10 to 1. It does seem to be what it wants, but if we go to gas temperature correction, what we can do is we can drop this down, and we can drop that down to 110 and see whether she still likes it. Okay, it doesn't seem to make any difference, so maybe what we need here is 105. These are just live experiments, guys. You can see that gas temperature falling away now. Look at that. So there it goes. It's going down to -10. So that's the vaporizer ultimately freezing up. Look, it's really nearly down to. It's really nearly down to. It is now down to -20. We have got some live data. If we view input data, we should have a true figure of gas temperature, and it's -20 or below. So, but the engine's still idling lovely. In fact, the idle's picking up, so we'll just knock it back down. And we're lovely idling at 1200 RPM. Still extremely rich, but that's fine. It does seem to be what the engine wants. It is a cold start after all. So we're still showing -20 on gas temperature. Let's bring that down there. Okay, so let's have a look here. Coolant temperature's up to 22. Okay, so AFR is still around about 10 to 1, super rich, but she's running lovely. There's a lovely start, seems to be idling nice and sweet. And what we'll do now is we'll just blip the throttle and we'll see if that comes down even further, because all gas demand will lower temperature. Well, it revs lovely. It seems very happy. You can see the AFR's just come up to about 11 there on a rev. So this is a very cold engine. We can't record anything lower than -20 here, so that really is the limit of it. What I'm going to do now is take you out of the car and have a look at the vaporizer, see if it's freezing up. And we'll also have a look at the LPG fuel filter, which in my experience can freeze as well. But she's running lovely. So here we go. Let's have a look at the vaporizer. So here's the vaporizer here. We've got no freeze up at all on the vaporizer. I'm touching it now. It's fairly warm. At the end of the vaporizer where the valve is, it is freezing cold. But here's what we see. Here's the frost. The frost is actually in the filter. So I'm just going to scrape a little bit off here. That's all frost. So the main point of weakness with the system is the freezing of the LPG filter. This is why it's mounted here right by the exhaust. Radiant heat from the ACT piece is designed to radiate over that filter to stop freezing up. As we follow the path of the LPG along, we find the LPG injectors. I don't see any frost here. They are freezing cold. They are designed to work down to -20. They are freezing, but they're not picking up any water from the atmosphere. So the only freeze up we see is coming from the filter. I don't see it's a major issue as it's still supplying fuel. There's no complete lockup of frozen fuel, so it's working well. So the system is working as good as we can get it, I think, guys. Right, let's hop back in the car, knock some revs off, and then we'll see where we are. So first of all, we've risen to 39 degrees, the typical temperature really where you would change over to LPG on a normal LPG conversion. We're going to knock some RPM off. Let's bring it back down. Okay. Right. Now, that is pushed fully home. Okay, doesn't need any air at all. Idles are lovely at 1000 RPM, or just over. So looks like 1040, 1050 RPM, just over 1000 RPM, but more or less. We do have closed loop idle management via scatter spark. So I'll just show you those figures. Might be interested. Basically, what it'll do is it'll add 4 degrees of ignition timing, and it'll check every 1.8 seconds. And here's the little correction table here where you can see how many degrees it actually adds in a go based upon the number of RPMs over or under the target. So that's how that works. You do need to see that the target is 1000 RPM. Okay, and you do need to see actually that closed loop idle only starts to happen at 40 degrees C anyway, which is where we're at now. We're actually at 65, you can see that behind. So there we are, 65. So it was at that point that we reached 40, I knew I could knock all the air off because closed loop idle through scatter spark takes over. Okay, we can see also now, interestingly, it's running 30 degrees at idle. Alright, so if we go to the ignition map, so this is the secondary ignition map, which is LPG, we'll see actually my target is 30 degrees. That sounds like a lot for you petrol guys, but basically with LPG that's what it wants. So in actual fact, it doesn't need any air and it doesn't need any timing to hit the 1000 RPM target after it's reached 40 degrees. It does seem that richer mixture helped it warm up quicker as well, so while it's quite scary to see these figures of 10 to 1, I think that's what it needs, guys, just to have a nice reliable smooth cold start and warm up phase. Now we'll come back down here and we'll have a look and we can see. So remember, earlier we saw on first startup, temperature fell to -20 or possibly below, because that's my lowest reading, and is now back up, just reaching above 0. So we've obviously got this enrichment still. So this enrichment is still happening at 110. In fact, it's between 110 and 105. So it's more like 107% of, 7% additional enrichment. We can also see up here that the running temperature correction is now at 100. Okay, so that means that there is no correction. So the only correction we're getting is on LPG now, not on the petrol map, and the only correction is now coming into around about 5%. We can see here, but by the time that the LPG temperature gets up to 20 degrees and above, which is normal running temperature, the correction will be 0 as well, which is ideal. So we're correcting on the ignition timing by 2 degrees here, so just holding it up to 1000 RPM target by adding 2 degrees, which is nothing at all really. And we had a lovely cold start on LPG there. Only the filter freezes up. We're going to go under the bonnet now and have a look at that filter again and see what's happening. Before we do that, we'll double check the AFR. So we got a nice 13 to 1 there, which is nice, as we're still not fully warm. Coolant temperature's at 78 degrees, and oxygen on the CanM software is matching the 13 to 1 figure basically. So let's look at that again. So it's sort of 12s to 13 really, basically. So that's lovely for a cold start, since we're still not out of cold start. So that only additional fuel is coming from here, which is, if I could get the damn thing to focus, gas temperature correction, which is just roughly around about 3% at this moment. It does also go into closed loop fueling, so where it references AFR against the target AFR map. I won't bother to show you that now, but what I can tell you is it's designed to idle. We're in about 13.8 to 1. That's a nice idle for a TVR, even on gas. So that's how that works. Right, let's go back under the bonnet and see what we've got in the way of freeze up on that filter. Completely gone. So you can see how my system is designed. Radiant heat coming off here, that's actually hurting me now. That's very hot there. Radiant heat has come off of the exhaust and has warmed this filter body, which is now warm to the touch, you know, not baking, but warm to the touch. So the system has worked well. The radiant heat from the exhaust has warmed the filter. As we can see here, the vaporizer is fine, always was. That's an amazing Magic Jet Power 3 vaporizer. A little bit too hot to touch actually now, because it's taking all the coolant in. The coolant is hot. The Magic 3 Power vaporizer really is a brilliant thing in terms of cold starts. Got a lot of guys out in Poland using it down to -20 ambient temperatures. I don't have an issue with that at all. That's fantastic. And once again, we're over here now with the injectors. These are Hannah Golds, very good injectors. Still a little cold to the touch, so we're still getting cold fuel in there, but they're going to be warming up nicely on the top of the rocker cover. We'll go back in the car now and just check the throttle response, and that's one warmed up car. So as you can see, it's not strictly the case that you can't start or cold start a car on LPG if you've got the right systems. Right, let's see how she responds to the throttle. Yeah, that's fine, man. She's all good. Okay, quick little look at the data again, and then we'll call this video done. An LPG cold start's a success, and I'm pretty confident this car is going to be able to cold start and be driven straight away from ambient temperatures as low as -5, but we haven't had that weather yet. Apparently tomorrow's going to be cold, so we give it another go.